Hello students, welcome to YouTube channel Vidya for Success. Dear students, in today's session, let us continue our discussion with continuous frequency distribution. To understand, to put forward the data in a continuous frequency distribution, we need to study few terminologies. So in today's class, let us continue our terminology studies. So another important terminology is called as open-ended class. Open-ended class. So what is this open-ended class? Let me explain it with an example. Less than 10, 10 to 20, 20 to 30, 30 to 40, 50 and above. So this is the class interval. Corresponding, we will be having certain frequency. So if you notice this class interval, if a class is having, or else if there is not a mention of lower limit or upper limit, then that class interval is referred as, or that class is referred as open-ended class. As you can notice here, less than 10. So less than 10 means what? It can be 9, it can be 8, 10, 0, minus something, minus 5, minus 8, whatever may be the value. So we don't know what is that lower limit. If the lower limit or the upper limit, if they are not specified in a class, then such a class is referred as open-ended class. Okay. So followed by this, we need to understand here either in some of the frequency distribution we will be missing the lower limit or we will be missing the upper limit, but nowhere we will not be missing both the lower and upper limit. Either any one, either lower limit will be missing or upper limit will be missing. So such a class is referred as open-ended class. So followed by that, let us also study what is meant by midpoint. Okay. So the next terminology for us to understand is midpoint of a class. So what is that midpoint of a class? Let us say that we are having the following class interval: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 50 to 60. Let this be the our class interval. So what is a midpoint? Midpoint is nothing but the central value of a class interval of a particular class. So what is the central value of the class 0 to 10? What is the central value of the class 10 to 20? So the midpoint of a class is also referred as class mark. Okay, it is also referred by the name class mark. So what is the formula to find the midpoint or class mark? So usually the midpoint is also referred by the name class mark. It is also referred by the name class mark, and it is denoted with the symbol either small m or small x. So we will be using the alphabet small m or small x to indicate the class mark or midpoint. So how to find the midpoint? So the midpoint x is equivalent to lower limit of the class plus upper limit of the class divided by 2. Let us say that we want to find the class mark or midpoint for the class 0 to 10. So the lower limit of the class 0 to 10 is 0. What is the upper limit? Upper limit is 10 divided by 2. That is 10 divided by 2 is 5. So 5 is the midpoint or class mark. Similarly, if I am asked to find what is the midpoint of 20 to 30 class, so the midpoint is The lower limit of the class 20 to 30 is 20, the upper limit is 30. So, 20 plus 30, that is 50, divided by 2 is 25. So, 25 is the midpoint or class mark of the class 20 to 30. Okay. So, this is the formula. You need to memorize this particular formula. You need to understand once again. Okay. Followed by this, and the next topic, next terminology is called as width, W-I-D-T-H, width of the class. Okay. Width of the class, also referred by the name size of the class. So, what is width of the class? Width of the class here. What is the width of the class? 10 to 20. For example, let us say that there is a class by the name, by the 30 to 40 is, sorry, 30 to 20 to 40 is one class, followed by 40 to 45 is another class, 45 to 50 is one more class. Whether the width is same for all the classes? No, there is a change in the width. So, for the first class, that is 0 to 10, the width is 10. For the second class also the width is 10, but for the third class 20 to 40 the width is 20. Next, for the fourth class, it is 40 to 45, the width is 5, followed by the fifth class 45 to 50, the width is again 5. So, then what is width of the class? So, the width of the class is the difference between the upper limit and lower limit. Okay. So, what is width or size of the class? So, the width or size of the class is indicated with the notation small c or small I. So, what is width? Width c, small c, is equivalent to the difference between the upper limit and lower limit of a particular class. So, the difference between the upper limit and lower limit of a particular class is referred as width of the particular class. For example, what is the width of 10 to 20 class? The width is 10, that is 20 minus 10 is 10. What is the width of the class 20 to 40? So, the upper limit is 40, the lower limit is 20, so the width is 20. Okay. So, this is how you are going to find the width of the class. Width of the class is indicated with the notation small c or small I can also be used. Next, followed by this, next terminology is number of classes, number of classes. Number of classes. So, let us say that we have conducted a survey. After conducting a survey, we have collected data from 50 families. Okay. So, from 50 families we have collected the data. Now, we need to put forward the data in terms of table, that is frequency distribution table. So, at the time of representing the data, we may be choosing continuous frequency distribution. Okay, let us go with continuous, not with discrete, let us go with continuous frequency distribution. So, at the time of considering the continuous frequency distribution, we need to decide how many classes must be there in order to display that entire data of 50 families. Okay. So, let us say the class interval, the number of classes may be like this, 0 to 10, maybe 10 to 20, 20 to 30, 30 to 40, 40 to 50. So, here how many classes I have used? Here I have gone with only 5 classes. So, the next terminology what we are studying is number of classes. For a given data, if we have been asked to present the data in a frequency distribution, that too continuous frequency distribution, we need to decide how many classes we need to go with. That can be computed by a particular formula given by Professor Strugi. Okay. So, the Professor Strugi rule, there is a rule by the name Strugi rule, it is given by Professor Strugy. This rule is referred by the name Strugy rule. So, what is this rule? So, this particular rule is used to identify the number of classes. So, that is the number of classes is indicated with the notation small k. K is equivalent to 1 plus 3.322 log n. So, this is the formula we are using to measure or to come up with what should be the number of classes for a frequency distribution, that to continuous frequency distribution. Okay. So, here what is log n? So, here n, capital N is nothing but number of observations. Okay. So, what is capital N here? Capital N here is nothing but total frequency or number of observation here. That is, as I told you, we will be conducting a survey on 50 families. So, here what is capital N? Capital N is 50. So, these 50 datas what we have collected by visiting 50 families, they will be split into different classes. How many classes? That can be computed using the formula k is equal to 1 plus 3.322 log n. So, what is n? N is number of observation. Very simple. Okay. Next, followed by this, we also need to know what should be the width of each class. First of all, for a given data, we need to find how many classes we can go with. Later on, we should also decide what should be the width of each class. What should be the class interval or what should be the width of each class. So, the width of a class, can be easily founded by the formula range divided by number of classes, that is range R divided by k, small k. Okay. So, we will be collecting the data by visiting let us say 50 families. These 50 collected data need to be presented in a table. So, first of all, we need to decide how many classes we need to go with. So, how many classes we need to go with? First, we will be deciding. That will be decided by the Strugy rule. Followed by that, next we need to decide what should be the width of each class. So, that can be easily computed using the formula. Width of a class is equal to range divided by number of classes. Already we know what is meant by range. Range is nothing but highest value minus lowest value, that is the range. So, the range divided by number of classes will give you the width of the class. Next, followed by this, now let us study one more important terminology, that is cumulative frequency. Cumulative frequency. Cumulative frequency. Let us consider a class interval or else frequency distribution table. Let us say the frequency distribution is 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Followed by, let us also consider the frequency. So, the first column indicates the weights, let us say weights in terms of kg. The second column indicates number of students, okay, number of students. Let us say that in the first category there are 8 students, in the second category there are 12 students, again 10 students, here 5 students, again let us say here 5 students. Okay. So, totally what is the capital N value here? Capital N is 20, 30, 40. So, there are 40 students, their weights have been classified and they have been put forward in a continuous frequency distribution table. Okay. Please notice here, out of 40 students, 8 students, they are having a weight of between 20 to 30 kg. Around 12 students, their weight comes between 30 to 40 kg. Similarly, there are 10 students whose weight comes between 40 to 50 kg. So, what is this cumulative frequency? Before that, we need to understand what is frequency here. So, what is frequency? Frequency is number of times of occurrence of a particular value. Okay, what is frequency? Number of times of occurrence of a particular value. Already I have told you in the previous video. For example, in a given number, let us say 522 to 1, here what is the frequency of the digit 2? The frequency of the digit 2 is 3. In the same way here also, we will be first of all plotting the frequency distribution table. Later now we need to find what is the cumulative frequency. Cumulative frequency is nothing but added up frequencies. Okay. For example, here we will be adding the frequencies. 8 plus 12 is 20, 20 plus 10 is 30, 30 plus 5 is 35, 35 plus 5 is 40. So, this is a added up frequency. They are called as cumulative frequency. Why we need to study this cumulative frequency? Suppose someone asks us, how many students are below the weight 50 kg? Okay, we need to say exact number, how many number of students are there below the 50 kg mark, or else certainly someone asks us how many number of students are above 20 kg, then we need to say the exact figure. In order to convey this, we will be using the cumulative frequency. What is cumulative frequency? Nothing but the added up frequencies. In cumulative frequency, there are two different types. There are two different types in cumulative frequency. The first one is referred as LCF, another one is MCF. LCF is nothing but less than cumulative frequency. MCF is more than cumulative frequency. So, what is LCF? Less than cumulative frequency. Please notice here. First of all, let me plot the LCF values here. Very simple. LCF values to get the LCF values. You go on adding this frequency. So 8 plus 12 is 20, 20 plus 10 is 30, 30 plus 5 is 35, again 35 plus 5 is 40. So you will be getting the capital N value, total frequency. Okay, so this is LCF. So why we need to consider LCF? If someone asks us what is the number of students below 30 kg. So, below 30 kg, there are only 8 students. So, LCF always, it will be studied or else it will be compared against the upper class, upper limit of a class. Always, this LCF will be studied against the upper limit of a class. Okay. For example, I want to know what is the number of students below 50 kg. So, below 50 kg, there are totally 30 students. As I told you, the LCF, what is LCF? Less than cumulative frequency. That is the frequency distribution formed for less than cumulative frequencies against the upper class limit. Against the upper class limits. So, you will be studying these LCF by considering the upper class limits. Similarly, I told you there is another type of frequency called as MCF, that is more than cumulative frequency. So, what is more than cumulative frequency? Nothing but, please notice here, I will start with the capital N value, that is total frequency, that is 40. So, okay, 40 minus 8, 40 minus 8 is 32. 32 minus 12 is 20, 20 minus 10 is 10, 10 minus 5 is 5. This is MCF, more than cumulative frequency. That is, what is more than cumulative frequency? If we want to know how many number of observations are above a particular mark, then we will be considering more than cumulative frequency. So, what is the use of more than cumulative frequency? It is used to study what is the number of observation or what is the frequencies that are above a particular limit. For example, please notice here, if someone asks me what is the number of students above 10 kg, so above 20 kg, so above 20 kg there are 40 students. So always MCF, more than cumulative frequency, will be studied against the lower limit of the class interval. Okay. So if someone asks me what is the total number of student above 40 kg, so above 40 kg there are 20 students. Please notice here, I am studying MCF against the lower limit of the class. Similarly, if someone asks me what is the number of student number whose weight is above 60 kg, there are only 5 students. Okay. So, what is cumulative frequency? Cumulative frequency is nothing but added up frequencies. Why we need to consider added up frequency? To study the precise number either above a particular limit or to below a particular mark, to study that. Okay. There are two types of cumulative frequency. The one is less than cumulative frequency. It will be studied against the upper limit of the class. And the second one is more than cumulative frequency. It will be studied against the lower limit of the class. I hope you have understood. The next terminology we need to study is frequency density. Frequency density. Okay. So, once again let me consider a frequency distribution table. Now we will be studying frequency density. Frequency density. So, what is frequency density? Let me explain it with a frequency distribution table. Let the class intervals be 0 to 10, 10 to 20, 20 to 40, 40 to 45, 45 to 50. These are the different class intervals. Followed by, let us also consider the frequencies 10, 15, 40, 45 and 20. So, these are the corresponding frequencies. Now, what is frequency density? What is, before that let us study one more terminology. What is class frequency? Class frequency, very easy. It's not it will not be explained in your textbook. Class frequency. Class frequency is nothing but a frequency corresponding to a particular class. What is the frequency corresponding to the class 10 to 20? It is 15. What is the frequency corresponding to the class 40 to 45? It is 45. What is the frequency corresponding to the class 0 to 10? It is 10. That is called class frequency. To a particular class, what is the frequency? That is class frequency. But what is frequency density? Please observe here. Each class is of different width, of different size. Here the size is 10, here 10, here 20, here 5, here 5. So, per class, what is the frequency that we need to study? What is that ratio for a particular class? For class width as well as the frequency, that ratio is referred as frequency density. So, what is frequency density? The frequency density is nothing but frequency density FD. Frequency density is nothing but frequency of a class divided by width of the class. Width of the class. For example, let us study the frequency density for the class 10 to 20. So, what is the frequency of the class 10 to 20? It is 15. What is the width of the class? The width of the class is 10. So, what is the frequency density? 1.5 is the frequency density. Now, let us study the frequency density for the class 20 to 40. 20 to 40. So, what is the frequency of the class 20 to 40? It is 40. What is the class width? Class width is 20. So, that is 21s or 22s are. So, the width is the frequency density is 2. Okay, so the frequency density, there may be a change. It all depends upon what is the width and also what is the frequency. So what is frequency density? Frequency density is equivalent to the frequency of the class divided by width of the class, or else it is the ratio of frequency and width of a particular class. Followed by this, another last terminology is relative frequency. Relative frequency. Relative frequency. Okay. So what is relative frequency? Very simple. Now let us add all these frequencies. Okay. So 10 plus 15, 25, 25, 65, 65, 100, 110, 110 plus 20 is 130. 130 is the total frequency. Total frequency. Okay. So that is N, capital N is 130. So 5, 10, 1, 2, 3, 7, 7, 11. So it's correct, 130. So 130 is the total frequency. Now, what is relative frequency? Very simple. Relative frequency is equal to frequency divided by total frequency. What is relative frequency? The relative frequency is nothing but frequency of a particular class divided by the total frequency. That is called as relative frequency. For example, what is the relative frequency for the class 20 to 40? The frequency of the class is 40 divided by what is the total frequency? 1 by 30. You will be getting some value. Okay. So this is what relative frequency is. Okay. So what is relative frequency? So relative frequency is nothing but it is a ratio of frequency of value of the variable to the total frequency. So for a particular class there will be a frequency. What is its ratio with respect to the total frequency? That is called as relative frequency, or else relative frequency usually it will be referred by as RF. So these are the different terminologies which are very important before plotting a continuous frequency distribution. Thank you.